Hi everyone, in this video you will learn theorems for right angled triangles and in specific the hpq theorem. As you have already learned about the Pythagorean theorem and about the Bach theorem, today we're going to have a look at the hpq theorem. First of all, I'm going to show you an example and afterwards I will show you the proof. So, an example. You must know that the hpq theorem is the same as h squared equals pq. Please remember that there is an invisible multiplication sign in between p and q. So you have h squared equals p times q. So what is p, what is q, and what is h? Please remember that opposite of vertex C, we have hc. Opposite of vertex A, we have HA, and opposite vertex B, we have HB. And the height is the altitude of this right angled triangle. The hpq theorem can only be used in a right angled triangle. The P is AD and Q is BD. This is because HC is split up in two parts. As you might have already seen, HC is the longest side of triangle ABC, since it's opposite of the right angle, and that means that this is the hypotenuse. So we split the hypotenuse in two parts. So we need to calculate AD, but how do you know which theorem you need to use? So first of all, let's have a look at the Pythagorean Theorem, because this is the most common one. Can we calculate an edge? No, we cannot. We cannot calculate AD since we only know the adjacent of DC, but we do not know our hypotenuse of AC. Can we use the Bach theorem? No, we can't, because as you can see, we only have two values, and that's too little to calculate with the Bach theorem. So we're going to use the hpq theorem, which is h squared equals pq. That means that we have a look at h, which is dc, so this is a c, or cd, squared equals ad times bd. It's a must to write down the letters as well. cd is 4.5, so you get 4.5 squared equals ad times 3. 4.5 squared is the same as 20.25, and 80 times 3 equals 3AD. We want to know what 1AD is, so therefore we need to divide everything by 3. So AD is 6.75. Please always give a conclusion, so AD is 6.75 centimeters. Alright, so this is an example how you can calculate edges with the hpq theorem. But how and why are we allowed to use this? If you have difficulties with this chapter, then especially with this topic, then just skip the proof, because the proof is way harder than the proof of the Bach theorem. But if you want to have a little bit of a challenge, then please have a look. So again, what we know is that opposite of our B vertex, we have our HB. Opposite of A, we have our HA, and opposite of C, we have C. This is the altitude, so the height is h, and c is divided in p and in q. What we know in our big triangle, so in ABC, that a squared plus b squared is c squared, since c is our longest edge. In triangle ACD, we have h squared plus b squared equals b squared, since this edge is opposite to our right angle, and that means that this is our longest edge. So as you can see, both of the times we use Pythagoras. Again, the Pythagorean theorem for BCD, it says h squared plus q squared equals a squared. If you add those two triangles together, so the two small triangles, then of course we will get a big triangle. So what we have is 2h squared plus b squared plus q squared equals a squared plus b squared. As you can see now, a squared plus b squared was c squared. So we can just replace this. So therefore 2a squared plus b squared plus q squared equals c squared. However, c squared is p plus q squared because c is made up of p plus q. If you're going to multiply out of brackets, so p times q, q times p, and q times q, you will get p squared plus 2pq plus q squared. So I'm going to replace this for our c squared. So what we get is 2a squared plus b squared plus q squared equals p squared plus 2pq plus q squared. Now I'm going to use the balance method to simplify everything. So I'm going to subtract p squared on both sides. So that means that p squared is going to disappear. I'm going to subtract q squared on both sides. So that also means that it's going to disappear. So the only thing we have left is 2h squared equals 2pq, which we divide by 2, and then we get h squared equals pq. And this is how we have proven that our hpq theorem works for all right-angled triangles. If you have any more questions, then please let me know. And otherwise, make sure that you practice a lot and that you do the exercises, and most of all, that you check them.